Under example 12, the function f and g are defined by the function f is defined by the modulus of 2x minus 8, and the function gx is defined by x plus 1 all over 2. And part A is just quite a simple question. We are supposed to find f, g, 3. And again, this is just what we have seen, and we are starting from the right hand moving to the left. So we start from our g3. Our g3 is simply 3 plus, because this is the function g, 3 plus 1 over 2, which is a 2, because 4 divided by 2 is a 2. Now, f2 is going to be the modulus of 2 multiplied by 2 minus 8 modulus, and then it becomes the modulus of 4 minus 8 is actually minus 4 modulus, which is simply a 4. Remember what modulus means. It is an absolute value which is not negative. Part B of the question is, and this is where we need to pay a bit of attention. Solve f gx is equals to x. Solve f gx is going to be equals to x, and that is just part B. First of all, what is gx? Of course, you can see gx is that. So we are supposed to start from right to left. So f, the solution after effecting x upon g, is going to be modulus of 2 x plus 1 over 2, because gx is x plus 1 over 2. Whatever the value of x is multiplied by 2, because now we are affecting this solution upon the function f, which is this. And if this is just x, then this x, the whole of this x, gets there, and 2x is the one that is giving us 2x, because our new value of x is as a result of gx, which is x plus 1 over 2. Of course, minus 8, and finally modulus. And because this is just one bracket, we can have cancel out 2 by 2, and this is going to be the modulus of x plus 1 minus 8, which is basically the modulus of x minus 7. This is now the FGX. At the point where, and this is the most interesting part, at the point where FGX is supposed to be equals to x, these are two simultaneous equations, and we should solve them simultaneously, and we have known what we've been doing at least to achieve the value of this. We can solve it graphically, but let us see why we need to solve it graphically. We have to have two equations. One equation is going to be FGX, which is the modulus of x minus 7, and another equation is going to be y is equals to x. We should solve those two equations, of course, graphically. If we start with this, let us have y is equals to x minus 7 before it is moduled, because modulus means is going to be reflected along the x-axis. If we may have table of values. When x is 0, y is supposed to be -7, and y modulus is supposed to be now +7. When x is, let's say, something to do with 7 even, when x is a 7, you can see 7 minus 7 is going to be 0, and of course 0 module is going to be 0. But let's see, when x is probably a 10, what happens? Y is supposed to be 10 minus 7, which is a 3, and 3 module is still going to be a 3. But of course you can see, if we can talk about sketching this curve or this graph, we are going to have, when x is 7, then y is 0. When x is, let's say, 10, y is, let's say, 3. This could be a 3. So we are going to have a point, a line that moves that way. But it is very interesting that when x is supposed to be 0, as you can see, when x is supposed to be 0, then y ordinarily, before its module, is supposed to be -7. But because we are talking about module, then this is reflected along the x-axis, and it simply becomes +7. So we are having a graph that looks like that. So this is just this is the y is equals to fgx. That graph you can talk about is reflected along that at that particular vertex, because it lies exactly on the x-axis. Another graph we should have in the same set of axes is y is equals to x. And this graph of y is equals to x, when x is 0, y is 0. When x is 7, y is 7. When x is 10, y is 10. And we should talk about a graph that possibly, let it pass through the origin. Let us allow it to pass through the origin. We are talking about a graph that possibly this is y is equals to x. What I wanted us to capture in that particular graph is that it is possible that the two graphs meet only once. And you can see the graph y is equals to x meets the graph y is equals to fgx, where the line is red. And this red line means it is the moduled part of the graph. What does that mean? It means, therefore, it was supposed to be the negative part of the graph. What we are saying is that if we consider the negative part of this, then we are bringing it like minus x minus 7 is supposed to be equals to x. When you open this graph, we're going to have minus x plus 7 is equals to x. If you cross over negative x, we are going to find 2x is equals to 7. Divide by 2, divide by 2, and finally x is 3.5. Quite a serious question, and I hope that we have followed. The most important part of this question is coming up or sketching the graph of the two equations, but of course highlighting the moduled part with a different color so that you don't make mistake. If, for instance, the line cuts the y-axis along this particular line, which is black, probably we may be just interested. Let's see whether they meet. Then we should be having x minus 7 is equals to x. And this one is not going to work because, I mean, if you bring x along, because it's the positive part, if you bring x on the other side, then you're going to have minus 7 is equals to x minus x. And minus 7 is equals to, is supposed to be equals to 0. and such a relationship does not exist. So minus 7 is not equals to 0. Since minus 7 is not equals to 0, then the two lines do not intersect in any other point. This is enough proof. All right, so we only have one solution of x. Okay.